At the IABG National Space Center near Munich in Germany, the Solar Orbiter spacecraft undergoes crucial tests for its mission to observe our nearest star. The Sun is an essential part of our solar system, providing the Earth with heat, light and life. But before Solar Orbiter gets to study the Sun's features, activity, solar wind, electric and magnetic fields, engineers must be certain it can withstand the stresses of launch.
What we do in these vibration tests, we put them on a table which is very well lubricated with oil, and we use some what we call voice coil actuators, which is basically very powerful loudspeakers, and we do a vibration movement of the spacecraft longitudinally and then laterally, and what we try to see is the resonant frequencies of the spacecraft. The spacecraft behaves like a bell, and then once you hit on the bell, then it sounds on its natural frequency. So what we're now trying to measure is what are the natural frequencies of the spacecraft, and then in some cases that when we are exciting the spacecraft at those natural frequencies, that nothing breaks loose.
An international collaboration, the spacecraft was built and is being tested by Airbus. After the vibration tests, which can shake the craft up to 120 times per second, are the higher frequency acoustic tests. Then shock tests for when the spacecraft deploys its solar arrays, antennas or instrument boom. The high-gain antenna, used to receive telecommands and send data and images back to Earth, will use just 1 kilowatt of power, much less than a dishwasher. And the heat shields at the top of the spacecraft, which required specially made blankets, will protect the normal operating temperature of 30 degrees Celsius inside from much hotter conditions outside.
We're in an orbit which is about 160 days long. We go very close to the Sun, about 42 million kilometres from the Sun. It doesn't sound close, but it's actually much closer than we are from the Earth. And at that distance we will see power from the Sun about 12 to 13 times hotter than what we see here on Earth. That means the temperatures get very hot, over 500 degrees centigrade. But because we're in this long elliptical orbit, we'll also go out really quite far away from the Sun, so we'll actually get very cold as well. So we'll see this thermal cycling. Every 160 days we'll go hot and cold and hot and cold. And we do about 20 of those orbits for the complete mission of Solar Orbiter.
Solar Orbiter will also be up to 180 million kilometres away from the Sun. This allows it to make both in situ and remote measurements at different distances with some of its 10 instruments. To keep these instruments clean and to protect them from humidity, dry nitrogen gas is pumped through them 24 hours a day, a process that will happen all the way up to the Delta V launch vehicle liftoff. The joint ESA and NASA mission will launch from Cape Canaveral in early 2020. And these next few months are vital to ensure that Solar Orbiter is ready for the spotlight.